And welcome to Chapter 9, where we're going to be dealing with chemical names and formulas. In this chapter, by the end of this chapter, if I give you a formula, you're going to be able to tell me the name of that compound, and if I give you the name, you're going to be able to write out the formula. Alright, and in 9.1 here, we're going to start by giving you the rules about naming ions. Now, there are two types of compounds, or actually three types of compounds that you're going to be naming in this chapter. I'm just going to write them off to the side here. You're going to be naming ionic compounds, covalent compounds, and acids. Alright, so using some simple rules, you're going to be able to name these three types of compounds. So, starting off with ionic compounds, you have to first know how to name the ions. Now, ions are charged particles. Just like you have down here, the sodium has a +1 charge, the aluminum has a +3 charge. In this case, both of these atoms have lost electrons and give them the overall positive charge. When you're naming positive ions, and positive ions are called cations. Cations are named the same as the element plus the word ion. So this sodium +1 is simply called the sodium ion. Alright? Or the sodium cation. Similarly, this is called the aluminum ion, or the aluminum cation. So the name of the cations do not change from their base element. Now, as you scroll down here, we also have what are called anions. Anions are negatively charged particles. They become negative by the gaining of electrons. That's something that was covered in a previous chapter. Now, anions are named by changing the end of the element name to an IDE ending. So, in this first one, where you have O2-, that's obviously oxygen, but we call the anion oxide with an IDE ending. Nitrogen, which is a 3- charge in this case, is now called nitride. Alright? So that's all there is to it. Cations names do not change from their elements. Anions, the negatively charged particles, have an IDE ending. Now, if we scroll down, do you have to actually memorize all of this stuff? Well, you do have to know the ion charges, but you don't have to memorize them. It's actually fairly easy to figure out from the periodic table, and if you haven't covered some of the other chapters yet, what you'll notice is that if you are in the first column, they form +1 charges. If you're in the second column, the alkaline earth metal, they form 2+ charges. Skipping over the transition metals, which we'll talk about next, aluminum has a 3+ charge. When you get to the fourth column over, again, not counting the transition metals, you would predict that they would have a 4+ charge. Now, they do a lot of different things here. However, you do have tin and lead, and those both can form 4+, although they will also form some others, but they do form +4 charges. Now, starting at the far right, in the very last column, which is actually column 18 on our periodic table, if you wanted to label this would be 1, 2, and then going backwards, this would be 17, 16, 15, 14, and 13. And of course, you have the 10 columns across the transition metals. But anyway, column 18, or 8A, are the noble gases. They do not react, so these are all 0 charges. They do not form charged particles, for the most part. The halogens, being 1 away, will form -1s. The oxygen group, being 2 away from the noble gases, form -2s. And the nitrogen group, being 3 away from the noble gases, form -3. But of course, again, you do not have to memorize those. I will give you a table, or you actually have a table in your lab manual that has those charges in there. Alright? So, all of these cations are simply named after their elements. Lithium, sodium, potassium, rubidium, cesium as you go down the first column, beryllium, magnesium, calcium, strontium, and barium as you go down column 2, and then the aluminum ion. Again, as you go from down column 17, you'd have fluoride, chloride, bromide, and iodide. In column 16 here, you have oxide, sulfide, selenide. And in column 15, you have nitride, phosphide, and arsenide, although we usually don't use that here in the school anyway, so I wouldn't worry too much about that one. Alright, so you should be able to name ions. Now the transition metals are slightly different because transition metals can actually have different charges. Copper is a great example. Sometimes copper is a +1, sometimes it is a +2. Iron can be a +2 or a +3. Some metals, or some transition metals like manganese, can be anything from a +2 all the way up to a +7. So how do you tell the difference between these? You simply use a Roman numeral to tell the charge on that cation. So rather than just calling this the copper ion, we call this the copper 1 ion using a Roman numeral in parentheses. This would be called copper 2. Easy enough. Similarly, this iron, Fe, will be iron 2, while this iron 3+ is simply iron 3. It's just that easy. You just tell the charge on the individual ion. All right. Now, most of the transition metals will require Roman numeral. There are a couple of exceptions in there, and if you happen to miss those exceptions, I'll just simply correct you. We won't mark anything wrong. For example, silver, Ag, is always a +1. So we don't write silver 1. We just simply call it silver. The reason why these have Roman numerals is because they commonly form +1s and +2s. Iron commonly forms +2 and +3, but silver 99.99% of the time is a +1, so we assume that it is going to be that +1. But if you happen to throw a 1 in a Roman numeral in there, I'll just say, hey, that's not even necessary. It's not wrong, it's just not necessary. All right? So that is how you name these ions. And in the next podcast, we're going to talk about how you name what are called polyatomic ions. We'll see you next time.